Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. Security is no longer something that happens after the code is written. In modern environments, security is built into the pipeline, from the first line of code to the final deployment. Automation plays a central role in that shift, especially in DevOps and cloud-native workflows. In this episode, we examine two critical aspects of automation in today's cybersecurity toolkit: integrating security testing into continuous integration pipelines and using application programming interfaces, APIs, for Let's start with continuous integration and security testing. Continuous integration, or CI, is a development practice where code changes are automatically tested and integrated into the shared code base several times a day. Developers commit changes to a central repository, and an automated build and test process runs each time. This helps catch bugs early, reduce integration conflicts, and maintain a rapid development cadence. But CI isn't just for functionality testing. It's also an ideal place to implement security testing. By embedding security checks directly into the pipeline, you catch vulnerabilities early, when they're cheaper and easier to fix. This practice is often referred to as shifting left, because you're addressing security earlier in the software development. Let's look at a real-world example. A tech company uses a CI pipeline that automatically runs unit tests, integration tests, and static code analysis every time code is pushed to the main branch. As part of the pipeline, a security scanner checks for hard code credentials, outdated dependencies, and known vulnerabilities in third-party libraries. If a critical issue is found, the build fails and the developer is notified. The issue must be resolved before the code can move forward. This approach enforces security without slowing down development. Automated security testing in CI pipelines includes tools like static application security testing, dynamic application security testing, software composition analysis, and secret scanning. These tools analyze source code, runtime behavior, and open-source components to detect issues before the application reaches production. Static analysis tools scan the code itself, looking for dangerous patterns or insecure coding practices. Dynamic testing runs the application in a controlled environment and looks for vulnerabilities like SQ injection or cross-site scripting. Software composition analysis tools check for known vulnerabilities in open-source libraries. All of these checks can be run automatically and repeatedly at every code commit. The benefits of integrating security into CI are clear: faster detection of issues, consistent enforcement of policy, and reduced risk of insecure code making it into production. This also supports compliance efforts because you can demonstrate that security checks are applied consistently across development cycles. However, to be effective, CI security testing must be well-tuned. False positives can frustrate developers, while false negatives can lead to missed threats. That's why organizations should regularly review scanner configurations, prioritize critical issues, and provide developers with training and guidance on resolving common findings. CI security also benefits from strong integration with version control systems, issue tracking tools, and notification platforms. If a vulnerability is found, the system should automatically create a ticket, tag the responsible team, and include enough context for quick remediation. Now let's move to our second focus: API and integration automation. APIs, or application programming interfaces, allow systems to communicate with each other. In cybersecurity, APIs are used to connect tools, trigger actions, and share data across platforms. They form the backbone of security orchestration and automation. API automation allows you to build workflows that respond to events in real time. For example, when a threat detection platform identifies an infected endpoint, it can use an API to quarantine the device, notify the user, and open an incident ticket. No human intervention required. Let's walk through a practical scenario. A financial services company uses APIs to automate its incident response workflow. When a high-severity alert is generated by the intrusion detection system, the Security Information and Event Management Platform uses an API call to update the asset inventory, revoke the affected user's active sessions, and trigger a playbook in the response platform. That playbook sends notifications to security engineers and begins collecting logs from the affected system. This all happens in under 1 minute, far faster than a manual process. API automation also improves visibility. For instance, vulnerability scanners can use APIs to feed data directly into dashboards, reporting systems, or remediation workflows. This enables near real-time updates and allows teams to take action based on the latest risk information. APIs are especially useful in cloud environments where infrastructure is dynamic and scale matters. Cloud providers expose rich APIs that allow you to create, configure, and monitor virtual machines, storage, networks, and identity policies. With scripting and automation tools, security teams can enforce guardrails, detect policy violations, and roll back misconfigurations automatically. Let's take another example. A university runs weekly vulnerability scans across its hybrid cloud environment. When critical issues are detected, an API call is made to the configuration management system, which checks whether the affected systems are in scope for automated remediation. If they are, patches are applied and the system is rescanned. If not, a ticket is created and routed to the infrastructure team. This integration closes the loop between detection and response. APIs are also central to threat intelligence sharing. Organizations can use threat feeds and enrichment services to pull in data about new malware variants, suspicious domains, or known malicious actors. That information can be fed into firewalls, endpoint protection tools, or security information and event management platforms through automated API calls, updating defenses continuously. One powerful use of APIs is to support user lifecycle management. When a new user is onboarded, API calls can create accounts across services, assign roles, and send welcome messages. When a user leaves the organization, those same APIs can disable accounts, revoke tokens, and wipe devices. This not only improves security, but also ensures consistency and accountability. To implement API automation effectively, teams should use secure authentication methods like API keys or OAuth tokens, follow rate limits and best practices, and log all actions for auditing and review. It's also important to validate inputs, sanitize outputs, and use encryption where needed to protect sensitive data. Finally, as more platforms embrace zero trust, APIs will play an even greater role in enforcing access decisions, verifying device posture, and adapting policy in real time. The ability to script and automate across platforms is now a core competency for cybersecurity teams. To summarize, continuous integration and API automation are two pillars of modern cybersecurity. Embedding security testing into CI pipelines helps catch vulnerabilities early, reduce risk, and keep development agile. Automating security through APIs allows systems to talk to each other, share data, and respond to threats without human delay. Together, these practices move security from a reactive function to a proactive, integrated part of every process. For the Security Plus exam, expect questions about secure DevOps practices, automated security testing tools, and the role of APIs in cybersecurity workflows. You may see scenarios involving alert response, patch automation, or policy enforcement through scripting. Review terms like static application security testing, software composition analysis, OAuth token, API integration, and security orchestration. They're all critical for both the exam and the real world. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.